Hey, Sam. Well, so far, you are the lucky winner and the only attendee so far. Um, I I hope some more people should be filtering in. Sorry about the last minute scheduling issues. And you'll also notice it's me and not Miss Saunders. She's actually not feeling well today, uh, so I'm covering the class. She might be back on Monday, maybe, perhaps. All right. Time as we had for material anyway. So we'll go ahead and do that, and then we'll break for the weekend. And I might see you on Monday again. Maybe, maybe not. We'll see. Certainly, I will if you guys go to the 4 o'clock class. But anyway, spend a little bit of time reviewing what we went over on, or what you guys went over on Monday. That's the day that you guys did the thing. So we'll let processing start up. Here we go. Welcome to processing. Show this welcome message each time. No, thank you. Close. Okay, so on Monday, you guys basically got like the bare bones framework for a game down. Like it was nothing too crazy, but it was there. You could move a thing around. You could do game like things with it. So let's just go ahead and go over that code real quick. Does anybody remember what the X position and the Y position variables were meant to do? Yeah, pretty much. Yeah, for which direction to move. They hold the position of the circle that we use, and we can then change the position of that circle with our little movement keys. So yeah, it tells it basically which direction it's supposed to move because we increment or decrement either X position or Y position, and then it gets redrawn there on the next frame. Increase or decrease. And we had the background, but I actually found a much more red background, so I'm going to go with that one. 1F6, 0FF. There we go. And then we already know about the fill. It fills the whatever we're creating, the ellipse in this case, the um, with the um, with the color that we've denoted. Hey, Abigail. Glad you could make it. Your ears do not deceive you. I am not Miss Saunders. However, she is feeling unwell, so I'm covering for her today. But you are in the right class. All right, so that was the basic framework in order to get like the game even visible, but there was nothing we could interact with. So what we did is we created some movement commands, and we actually embedded those in a separate custom function. Get rid of that. And the move commands were just a whole bunch of if statements. Does anybody remember, or Miss Saunders may not have gone over it, which was no failing on her part. It wasn't actually in the slideshow. But like what two commands or what two statements might go inside this if statement to check and see if it's true? Yeah, that's one of them. So key equals W in this case. Actually, we'll keep it with that because I did a little bit different with the 4 o'clock class, but the game actually gets easier with the way I did it. So we'll keep it this way, actually. Ignore my earlier question. This is the one thing you're going to put into the if statement. So checking to see if the key was pressed, the last key pressed was either W, S, A, or D. And then, oh, thank you. That's very nice of you, Holly. It's good to see. Oh, you guys sped it up a lot. Okay. Well, we'll go with y position minus minus, y position plus plus, x position minus minus, and x position plus plus. Did you guys go over why, like in this case, the W and the S, it's going to be minus minus and plus plus? Yeah, sure. Because it seems a little bit backwards, right? Like it seems weird that you do that. Well, okay. So essentially, I'll bring up the window over here so that you can still see it, Andrew. Essentially, when you're looking at the game window, so like this is the window of our game, right? As far as the computer is concerned, the coordinates start up here in the top left. That is meant to be a 0. There we go. 0, 0, like that. So x actually gets larger the further we go to the right, and y actually gets larger the further down we go. So it's like the reverse of, if you've ever done algebra and worked with graphs and stuff like that, it's almost kind of the reverse of that. Not exactly, because x still increments to the right on an algebra graph, but y tends to increment when you go up. So like 0, 0 would be down here. But computers are a little bit different in that case, mostly because we've made it so that you can type on it like a book. You start up here and you type and you type and it goes down, and because as humans we read, or well, as Americans and English speakers, we read from left to right and from top to bottom. I shouldn't say as humans, that is entirely incorrect, but from left to right, from top to bottom. So for that reason, we just sort of figured, computers were going to be sort of like word processing machines and number crunchers and things like that. We wanted to give it the same kind of natural reading style, so we had it start up in the top left corner. So for that reason, if we want the circle to go upwards, we have to decrease y. And if we wanted to go downwards, we have to increase y, which is weird and seems a little counterintuitive, but it's something that you get used to, and it even makes a little bit of sense in its own weird way. Anyway, So you guys made the move command, you made the, the draw command, all that kind of stuff, and then we included a game over condition. Whoop. Let me find it again real quick. There we go. So we had this whole big old if statement that checked to see if the circle was outside of the bounds of the window. So if x position is greater than width, that is to say, if the x position of the circle is a value larger than the width value of size, or if the x position is less than 0. So again, the window runs from 0 to 1,000. So if it's less than 0 or greater than 1,000, it's outside the bounds. Or if the y position is greater than the height, or the y position is less than 0. Too many parentheses. So basically, if any of these statements are true, then this if statement is true, and the stuff inside of the curly brackets executes. Excuse me. Okay. So yeah, if any of these statements are true, then the statements inside of the if statement is true, and then the stuff inside of it executes, which is to turn the background to a nice black color and set the text to a certain size, and then display some game over text. More or less centered on the screen. So that's more or less where we left off. We can move this around. If we bring it off the screen, we lose. And we get a game over screen. Now we still have a way to unlose by moving back onto the screen. That's something I'll challenge you guys to address at the end of this lesson. Oh, you figured out how to do it? Nice. So then you're ahead of the curve. Let's say 490. That probably looks a little bit more centered. Yeah, much more centered. Oh, gotcha. You figured out that you can never lose. Gotcha. Okay, so you managed to find that out last time around. Nice. So that's what we went over. We're going to actually improve upon the program so it becomes a little bit more exciting, because we have a lose condition. We don't necessarily have a win condition, which not all games have it, like Minecraft doesn't really have a win condition. Dwarf Fortress doesn't really have a win condition. Well, Minecraft does have a win condition now. I take that back. It used to not have a win condition, but you can go to the end and stuff like that. Temple Run doesn't really have a win condition exactly. You just go as far as you can. Same kind of deal. So we're gonna make it so at least you can get a score that increments, because otherwise it's just kind of like watch the ball float. Oh no, it's all good, Sam. These things happen. You actually just all we've gotten to so far is review. So you haven't really missed anything yet. So yeah. So what we're going to do is we're going to increase the gaminess of the game, if you will, the game-like qualities. We're going to add a few new variables. And I'll go over these in each one of these in turn. So we've got 2 new ints and 4 new floats. You guys went over what ints represent, right? Short for integer. Maybe, maybe not. Well, in case you didn't, integers just represent whole numbers. So 1, 2, 3, 4, 5, 6, 7, -1,465,835, whatever. That's all integers are they're just whole numbers. No fractions, no decimal points, no nothing. That's it. Whole numbers. Easy as. Floats, on the other hand, are short for floating point number, and they represent decimal numbers. So a floating point number could be 6.07. It could also be 60.7. That's part of the reason why it's called floating point. At this, you can have, as long as it fits within the float, you can have any number of digits in front of the decimal point and after the decimal point. There's no real restriction. There are, in some programming languages, there are fixed decimal point numbers where you have to have like, maybe 2 digits before and 2 digits after. So even if you just wanted to represent the number 1 in like a fixed, it would be 1.0001.00. Whereas a floating point can just be like 1.0, or it can be like 1.000000000000000 if you wanted to. There's no real restriction on it. The decimal point can just sort of be like, ooh, I can be wherever I want. I can float over here if I'd like and turn into like a billion, or I guess that's a trillion, 10 billion, right? That would be 10 billion. I'm pretty sure. But anyway, the decimal the point can float around, so that's why we give it the name floating point. Um, I say we like I had any hand in that naming. I didn't, but regardless. Uh, so we've got score, which is pretty straightforward. We've got speed, which can potentially represent the speed of something, perhaps the circle. We've got rectangle x and rectangle y. And that's what rect is short for, is for rectangle. Um, and then we've got this ominously named final x and final y. Like, I wonder what that could be. So we've got these new variables in here. We've got to initialize them properly, right? Otherwise, weird things happen. Did you guys ever go over why you do this stuff, like setting score to 0 and speed to 1 and any other variables to like certain values when you create them? So like we created score and we created speed, and we made sure to set score to 0 and speed to 1, as you would do with like 90% of the time, pretty much 100% of the time, any other variable that you created. Do you guys know why you might do that? Yes, no, maybe so. Okay, well, essentially, um, when a computer is using a program, it uses memory, right? So if you start up Chrome or Internet Explorer or Firefox, hopefully you're not starting up Internet Explorer, but if you start up any of these programs, or like a game or whatever the case may be, whenever you start them up, they start using up memory. They grab chunks of memory and they go, okay, I'm going to use this for all of my calculations and all of my whimsical doodads and everything else that it needs in order to run. So it uses up memory, and it fills that memory up with information, and it reads that information as it needs and sort of does whatever it needs to do. And you go, okay, I'm done surfing the internet, so I'm going to close down Chrome. So you close it down, and it goes, I don't need that memory anymore because I'm no longer running. Bye, everybody. And so it closes down. And the computer goes, okay, it doesn't need that memory anymore. It's free. But computers, and this is, as you As you guys already know, computers are dumb. Not only that, computers are lazy. And so far, we have just given a completely glowing review of computers. Computers are dumb and lazy. Let's just get that out of the way right now. But what that means essentially is they say this memory is free, but they don't clear it out. That memory is still filled with whatever was in there last from Chrome or whatever using it. So it could be filled with part of a picture of a cat, or it could be filled with some information from the last web page you visited or whatever. If you're running a game, it could be some information on like a monster location and hit points and stuff like that. Whatever was in there last will still be in there. If we don't set a value here, like if we don't set score to 0 and we run the game, well, score gets assigned to a memory slot. It doesn't get set to 0, and it's suddenly going to be filled with whatever information was last in there. So now we're looking at a score of cat picture, which is not really ideal. Or we've got a speed of Facebook.com. It's not exactly how it works, but it's you can kind of imagine in your head how that's going to play out. Weird things will happen. Really weird things. Your program will do really weird things, and it will do different weird things every time you start it up. And that's not really ideal. We like repeatability, we like predictability. So what we do is, just to be sure, we set the values to an initial value that we can use or need for the program after we declare the variable. I know it's a terribly exciting story, and I really wish there were more, fire and planes in it or something like that. I don't know. But it's a thing that's necessary for making programs. Regardless, we've created our variables. We've initialized our variables for the most part. We've set our text size because we're going to start displaying the score. Now we need to do something with it. Well, almost. We're almost there. We've got one more thing we got to do. Is it 2575? 2575. Based on your knowledge of the code so far and how processing works, what do you think we've done here inside of void draw? If it helps, you can go up like a dozen lines of code, maybe 10 lines of code, and see a similar thing happening that can give you a clue as to what's going on here. And another clue, rect is short for rectangle. No tigers, huh? All right, well, fill, as you guys already know, fills a shape that you're about to draw with a value. In this case, 255. I don't know why we don't have any sort of consistency across the across these values, except for we can just do this. That'll accomplish the same thing as up here. And well, it won't. It'll accomplish the same thing we meant to do with using the values that we have up here. It's going to fill something with white, just complete white. Right, we haven't gotten to the point where the score changes yet, but we're going to get there. But it fills the screen with complete white, and it draws a rectangle. So it's going to, or no, sorry, not the screen. It draws a white rectangle. Good Lord, sentences are hard. Anyway, that's what those two lines do. They draw a white rectangle. And then we've got these next two lines here. Final x, there's that ominous name again, equals x position minus rectangle x, and final y equals y position minus rectangle y. What do you think those do? Well, I'll just go ahead and say it. They give you the distance in the x and y from the circle that you're controlling and the rectangle that you're trying to get to. So it's the x position of the circle and the x position of the rectangle. The difference between the two gives you the final x. And hey, Wyatt, I see you got the email. GoToWebinar, you have to you can only schedule classes out so far in advance, and it looks like we just ran into an issue with that, so we needed to create some new classes. I apologize for the mix-up on that, but yeah, I know it's not ideal, but it should be good to go for at least another few weeks. But yeah, the difference in the y position between the circle and the rectangle. I'm going to put the videos up on YouTube, Wyatt, so you'll be able to see what's been going on. So we spent a little bit of time reviewing, and then we started adding onto the program. I'll go ahead and I can put in the code into the chat box after we get through this chunk of code, so that everybody can check their code, and then you can go ahead and put it in. And then, like I said, the video will go up on YouTube tonight, later tonight, because I have slow internet that is powered by men on horses handing letters to other men on horses, as I've said before. But it will be available certainly tomorrow to watch. And also the information. No, it's AT&T. I have what started out as $20 a month, but shot up to $50 a month, and I get a whopping, like, I don't even know, like 20 kilobits per second upload speed. It's basically it's even slower than that. Like, I'm pretty sure there's a tiny. Yeah, it depends on where you are. I'm hoping that AT&T will speed up in the coming months once Google Fiber starts, setting up shop here. Really hoping, because I know that in like the Charlotte area, they're definitely better than they are in the Carborough area, and I have just the internet deal, the cheapest one, so it's pretty slow. But anyway, this is not about my internet. This is about the rectangle and its distance from the circle, which I have to admit is terribly exciting. But anyway, that's the whole reason we're calculating this, is so we can figure out whether or not the circle is touching the rectangle, so that we can then increase the score and increase the speed of the circle. And thus enters the challenge of the game. Bum, bum, bum. So, now we've got this weirdo if statement. But hopefully it will all make sense by the time we're done. If final x is greater than negative 25, and final x is less than 50, this is going to be a little bit different than what's written here. And final y is less than greater than negative 25, and final y is less than, good Lord, 99. So basically what's going on here, so as I said, these are the distances between the two, right? Now, this can go several different ways. let's say this is our rectangle. Wow, that's the straightest line I've ever drawn in paint. This one right here, I'm pretty proud of that one on the left-hand side. They will never be that straight again. Let's say we've got a few different situations here. We've got a circle that's here, we've got a circle that's here, we've got a circle that's here, and maybe we got a circle that's right here. Like almost touching it, not quite. And this is at 50 x and 50 y. Now this circle up here is at, let's say 60x and 30y. And the circle over here is at 20x and 40y. And this one down here is at 49, that's a 9, 49x, and let's say 51y. So it's like almost on top of it. And then this one is at 60x and 60y. So as you can see, we've got a whole bunch of different values here, and some of these, the x is smaller and the y is, larger. On some of these, the x is larger and the y is smaller, and some of these both are larger and some of these both are smaller. So it's possible, since the equation goes the final x is equal to the position of the circle x minus the position of the rectangle x, and the final y is equal to the position of the circle y minus the position of the rectangle y. It's entirely possible that either final x or final y, or both, can be negative values. Yeah, definitely. No worries, I can actually head back over to it right now, because that helps to explain the point more. So for that reason, we have to make sure that it's within a certain amount of values. Too far into the negative, and we have, here we go, we have a circle that's, whoops, we have a circle that's way far away, like way behind the rectangle. Too far into the positives, we have a circle that's way too far in front. Likewise with the y. Too far into the negatives, we have a circle that's too far above it. And then too far into the positives, I can't underline it because the GoToWebinar window is in the way. But too far into the positives, the circle is way below it. So if it's within a certain set of values, in fact, if it's within all four of these values, it is somewhere here touching the rectangle. Could be like any one of these positions, really. Although computers are generally fast enough that you won't be able to overlap the rectangle this quickly. It will probably start to touch it and the computer will go, okay, that's enough, and then it will register a hit, and then it will continue doing the thing that it's doing. But regardless, any of those values would really be acceptable values for this if statement right here. And it would cause the if statement to fire. Now, what exactly is going to happen, you might ask? Well, I'm glad you did, because man, this is where things get crazy. So score plus plus, we increment the score by 1. Speed plus plus, we increment the speed by 1. And then we got this curious little thing here. Rectangle x equals random 50, 950, and rectangle y equals random 50, 950. So what do you think these last two lines are doing here? I'll give you a hint. Random is a function that allows you to get a random number. And the 2 in here mean that feeding the 2 into the parentheses here means that we're going to get a random number somewhere between 50 and 950. So based on what we've used rectangle x for and what's going on here, what do you think is happening in these two lines of code? quiet group today. Okay, well, what's going on is like I said, we're getting a random number between 50 and 950, and then we're assigning it to these values. And these values determine the location of the rectangle. So basically, once you touch the rectangle, it's going to reappear somewhere else randomly on the screen. Just like pop up somewhere else, and then we'll have to go get that one. And then let's go ahead and write some text down here. Score equals plus score 1515. That's just a little bit of text in the upper left-hand corner of the screen that's going to display our score. Now there's one more thing that we have to do, and that is we have to make it so that the circle actually speeds up every time somebody grabs one of these rectangles. Whoops. And that's really easy to do. So before you had, I believe you guys actually had the x position equals x position plus 5 or minus 5 or whatever. A shorthand for that is plus equals or minus equals. It accomplishes the same thing. So this x position minus equals speed is the same thing as typing x position equals x position minus speed. It's just because programmers like to save themselves time, this accomplishes the same thing. Oops, minus equals, not equals minus. There we go. So with that, I'm going to go ahead and copy paste the code and put it to the chat box so you guys can review it at your leisure. And let's go ahead and give our program a run and see what happens. that was a really quick turnaround. Something's wrong. Never mind. So now we can tap a button and it starts off in its merry way, moving super slowly. But as we grab rectangles, gradually the circle starts to speed up and it starts to become, eventually, a challenge to keep it on the screen. Especially as you got to grab those ones down near the edge. And with that, we've actually created our very first game. If this is your very first game, pat yourself on the back. All first games start small. They're all like a Pong clone, or a part of a Pac-Man clone, oh no, or whatever. They always start small. Did. If they're not, well, congratulations on that too. Look at you, fancy programmer person. But from here on out, hopefully you realize that code isn't as scary. Code isn't arcane and mystical writings in the tome of technology that can summon forth demons and worlds unimaginable. No, it's just a bunch of code and art. And that code is, it starts out really simple, and then it just sort of, you build complexity on top of it more and more until you get something that resembles what you'd like to make. And as you get more comfortable with programming, you can start accomplishing more with less. As you get more familiar with the stuff that programming can do, that computers can do, you can start making more complex things with fewer lines of code. And it's all about just refining your arts and getting more proficient with it and faster with it and better at it. Harder, better, faster, stronger, if you will, if you're a fan of Daft Punk at all. Regardless, though, if you've gotten this far, congratulations on your first program. You made your first game way earlier in life than I ever did. So you already got a leg up on me. And I'm teaching you guys. The people have surpassed the master. Regardless, there are still a few things wrong with the game, as some of you have noticed already. You can, as we already pointed out, you can lose the game, and then you can unlose the game. Yeah, you can press any other button to stop the ball. So just in case you're worried about it hitting the edge of the screen, you can hit a random letter and just have it like stop moving. It's a handy little e-brake. You can have it like you'll notice here that the score doesn't reset because the game doesn't necessarily reset ever unless we reopen it. So we can have it so that the game resets. We can do things like it displays your high score. It, you know, gives you a nice little pat on the back and victory music when you win or get a new high score. Although that one's a little bit more time consuming. Whatever. We've got a whole bunch of different ideas that we can do. Look at that. See, I'm cheating. I'm a dirty cheater. Look at this high score. I've died 3 times, 4 times, 5 times, 6 times, 7 times. Ah! Okay, it's gone crazy. But I'm going to challenge you guys to do that. I'm challenge you guys to figure out a way to. That could be said, yes. Good point, Wyatt. I'm going to challenge you guys to figure out a way to keep the player a loser after they've lost the game, which is not a commentary on their ability to play the game or their ability as a person, or their qualities as a person. Just the fact that they lost the game. So some way to sort of lock it into the game over screen. Additionally, some way to start a new game where you reset the score and reset the position of the ball and everything like that and start over again. Maybe have something pop up and tell you that you've gotten a high score. This doesn't have to keep I will say this. You won't have to keep track of high scores between every time you start up the game. So let's say I click the X and I click run again. We can have the high score reset to 0 when that happens. I just mean if you code in a way to, let's say, get a game over and then start a new game without closing the window and running it again, maybe keep track of the high score then and see if you can't, increment that value based on whatever the user got. If it is the high score, that kind of a thing. Just stuff like that. I'm going to go ahead and I'm going to do the poll questions since, like I said, I do teach a class at 7, and I want to make sure I give you guys time for question and answer and some time to just sort of fiddle around with your code and ask me anything that you want about it. So I'm going to throw out the poll questions now. After that, if the usual, if you have any questions about anything, feel free to ask me. Doesn't even have to be about the program we've worked on. It could be stuff that we've done in the past or, general life questions, whatever. And then I think right at about 3 till 7, I'm going to pop off and go to do my other class. So poll questions incoming.